Okay, so one more section of new material in chapter 1, and then we'll go to the review and then get the test. It's the word problem section. Usually if a chapter has word problems, I shove them in the last section, and that's what happens here. Usually my word problem sections kind of tend to be a little bit easier and a little bit shorter than the other sections. I know a lot of students just, are intimidated by word problems, and if I can get you over that fear, that would be a great thing. This section is not intended to be ridiculously hard. If you just, go into this section with a positive attitude that you can do word problems, you might surprise yourself. Like I said, I don't try to pick the most difficult word problems, and if you just really are open to the idea that you might be able to do word problems, there's a good chance that you're going to do these well. And generally on my tests, it's not the word problems that students miss, especially students that are allowed to use a note card. So there's only just a few basic ideas that we need to remember for this section, and I'll kind of bring them up as they come up, but we have to remember something about areas of triangles and just a few little concepts, but as we need them, I'll remind you of them. So big thing in this is just to be able to translate words into an equation. And as I read through this problem, the first two words are a number, and the a number part of this, I gonna make that into a letter, and usually you make it into the letter X. So a number, I don't know what number it is. I need to give it a variable, so the number I'm looking for is X. And the next thing I see in this equation is the word is, and is going to be replaced with an equal sign. Generally, is in mathematics, especially in this sort of setting, is going to be reserved for an equal sign. And then the last part of the first sentence is a little the tricky part of this. I don't know if I left myself enough room, but kind of did. So the less than, you might be, wanting to put a less than symbol. That is a symbol that means less than, and maybe in a different context, the words less than would require a less than symbol. But in this context, I already have an equal sign. I've never seen a problem with an equal sign and a less than symbol. So this isn't the context for less than that we need. In this case, less than is going to mean subtract. Yeah, I usually say it's a subtract and switch the order. Some subtraction words, you leave the order of what's being subtracted. And so this less than, I'm going to replace with a minus sign. And when I have a minus sign that I need to shove into a problem, I need to put something to the left of the minus sign and to the right of the minus sign. And generally, what's written to the left of the word that means subtract, I write to the left of the minus sign. What's written to the right of the word subtract, what I replace it with goes to the right of the minus sign. Less than's one of those backwards ones. So one of the things that needs to go on the side with the subtraction is the number 12, because it's given to me as the number 12. And the next thing that needs to go on the side with the subtraction sign is as its square, and that means the square of the number, and for me that means the square of X. So 12 is going to be the number 12, less than is going to turn to a minus sign, its square is going to be the square of the number, which is X squared. If I put it like this, that wouldn't mean 12 less than its square, it would be X squared less than 12. And This is meaning the switching the order is switching the x squared and the 12. I'm done now with the first sentence. I made a number into x, I made is into equal, I realized that less than was a subtract, and it was a subtract that I needed to switch the order that the numbers or variables were given. 12 was given first, the words for x squared were given second. I flipped them and I created an equation. Now I'm going to solve this, and generally when you have an equation that has an x squared, an equation means it's an equal sign, if you have a problem with both an equal sign and an x squared, the proper way to solve it, or the most common way to solve it, is to set it equal to 0 and solve by factoring. When you don't have an x squared term, that's when you get the numbers on one side, the letters on the other, and you divide by the number in front of the x. But in most of the problems in this section, the equation I create is going to have an x squared, and when you have an equation with an x squared, the proper thing to do is this algebraically set it equal to 0, and then factor, and then set the factors equal to 0. So I have minus x from both sides to get the 0. And now I'm going to factor this side, and I'll just write down my template real quickly just in case you need that. The original problem has plus plus. My factors are plus plus. If the original problem is minus plus, my factors are minus minus. If the original problem is plus minus, my factors are plus and minus. And if the problem has a minus and minus, I get another plus and minus. This is a minus and minus, so I'm going to get a plus and minus when I factor this. And I don't need bottoms up because there's not a number in front of the x squared term. And then for the 12, I need, for my I'll get my signs in there. I spend the time talking about the signs, I might as well throw them in. For the 12, it's going to be either 1 and minus 12, or minus 1 and 12, 2 and minus 6, or minus 2 and 6, 3 and minus 4, or minus 3 and 4. Those have to be the lasts that I pick. And the pair that's going to work are the 3 and the minus 4, because 3 minus 4 is going to give me negative 1, and that's the number that's implied in front of the x. So I'm going to go plus 3 and minus 4, and now that I have it factored, I'm going to go x plus 3 equal to 0, and x minus 4 equal to 0. For the x plus 3, you minus 3 from both sides, and get one of the answers to this problem, which is minus 3. And for the x minus 4, you add 4 to both sides and get the other answer, 4. I'm done. I can check, but it requires me being clever to check. The answers to this problem, the numbers are minus 3 and 4. I don't really have to call them x because they're not named in the problem. But if you wrote x equal minus 3 and 4, it's okay as well. To show you why minus 3 and 4 are correct answers, I need to compare each number to its square. So if I compare 4 compared to its square, and the square of 4 is 4 squared, which is 16. The difference between 4 and 16, 4 being the number, 16 being its square, the number 4 is 12 less than its square because they're 12 apart. It says compare. I don't know, it doesn't really look like compare. Similarly, if I look at the number negative 3 and compare it to its square, the square of negative 3 is 9. And the difference between 9 and negative 3, that's the number, is also 12 less than its square. That's why these are correct answers, because the two numbers I put, if I compare them to their square by subtracting the square minus the number, I get 12, and that's why they're correct answers. I'll keep going. Hopefully that wasn't horrible. First problems are harder than the other ones because they're just they have a skill that you might not have dealt with recently. So when I get to these word problems, a lot of them have the word is in them, and the is going to be made the equal sign, and the words to the left of the are going to create what goes on the left side of the equal sign. The words to the right of the is are the numbers and letters that go to the right of the equal sign. So to the left of my equal sign, I need something to represent the square of a number, and for me that's not so hard. For the unnumber part of this, I'm going to put just an x, but on the left-hand side I need the square of a number, and for me the square of a number is just a number with an exponent of 2, because square means exponent of 2. So I've actually dealt with the whole first part of the problem. I have the left side of my equal sign. The only thing that belongs to the left of the equal sign are the words that are to the left of is, which is the square of a number. On the next side, the 12 is going to be the number 12, and more than is like less than. Somehow the than is a flipper. More than it's a plus, and you switch the order. It turns out that if you ignore switching the order on the more than, your equation won't really match the words, but it won't impact you getting the right or the wrong answer, because addition's commutative. So for the more than, I'm going to replace it with a plus sign, and then so I've dealt with the 12, I'm going to make the number 12. I've dealt with the more than, I'm going to make it a plus sign, and the last thing I need is the number, and I guess for the number I'm going to put the letter x. I'm only going to ever have one variable in these problems. If I get 2 letters, I won't be able to solve it. So again, just like less than, I switched the order of how the number and letters are being presented on the right side. When I create my equation, I'm going to switch the order, and I'm going to make this an x plus 12. So the first sentence gives me the equation. The second sentence basically says find these, so go ahead and solve the equation. Just like problem 2, because there's a square and an equal sign, it's best to solve by factoring, and you really can only get the right answer if you get it set equal to 0. And I always get the 0 on the side that doesn't have the x squared. In the last problem, I got the 0 on the right side because the x squared was on the right side. I get the 0 on the side that doesn't have the x squared. The x squared was on the right side, so the 0 got on the left side. In this problem, the x squared is on the left side. I need to get the 0 on the right side. So to get that 0 on the right side, I'm going to minus x and minus 12 from the right side. And to keep the equation balanced, I have to also do that from the left side. On the right side, I'm going to get a 0 when I do this. And on the left side, I don't have any like terms, so I just write everything next to each other. And that looks remarkably like the last equation. So it's going to have the same answers, I suspect. So just like the last problem, I'm going to make it an effort to factor this. And it has to factor the same way. So my first are a couple of x's, because I don't need bottoms up, because there's not a number in front of the squared term. This is the last row of my template, so the signs are plus and minus. And then my choices were minus 1 times 12, or 1 times minus 12, minus 2 times 6, 2 times minus 6, minus 3 times 4, or 3 times minus 4. And that's the pair that works again, because 3 minus 4 will give me the negative 1 that's implied in front of the x. So I go plus 3 and minus 4, still have the equal to 0. Then I go x plus 3 equal to 0, x minus 4 equal to 0. Here I subtract 3 and get x equal to negative 3. and here I add 4 and get x equal to 4. And here I put x in my answer. It hardly matters. This is kind of the same thing, because if I wanted to check these, I check the square of the number, which is like the 4. If I check the square of 4, which is 16, that has to be 12 more than the number. And is that 12 more than 4? So for 4 to be an answer, the square of 4 has to be 12 more than 4. And that gives me that. Similarly, the square of negative 3 would have to be 12 more than negative 3. The square of negative 3 is 9. 12 more than negative 3 is also 9. You don't really have to check these, but you certainly can. Sometimes the checking is a little more confusing than the problem itself. The next few problems talk about consecutive numbers and consecutive even numbers and consecutive odd numbers. And these are common things to ask, and in a problem that asks for 2 numbers and I see the word consecutive, then I have to search what's after consecutive. So if I see just consecutive numbers in a problem, then it's asking for numbers like 5 and 6 are consecutive numbers, or 19 and 20 are consecutive numbers. And if I just see the words consecutive numbers, I'm going to call one of the 2 numbers, because I'm looking specifically for 2 numbers, and then I'm going to call the second number one more than it. That's going to be the case in problem 6. Consecutive numbers problems usually ask for 2 numbers, and usually you call the first number x, the second number x plus 1. There may also be problems that somewhere in the reading of the problem it asks for not consecutive numbers, but it asks for consecutive even numbers. And for consecutive even numbers, I don't use x and x plus 1. Consecutive even numbers are something like 6 and 8. They're even numbers. They aren't next to each other because there's a 7 between them, but they're next to each other if I deleted all the odd numbers. 100 and 102 would also be consecutive even numbers. Again, they're not next to each other, but if I delete the odd number between them, then they're consecutive. And consecutive for even numbers, either one number, or maybe I'll call it the first number just because I might switch this up. So the first number I'm going to call x, and for the second number, so this one I probably should have called this the first number as opposed to one number. I'm not going to call it x plus 1, I'm going to call it x plus 2. The other thing that I might see in a consecutive number word problem is the word consecutive odd numbers. And if in a word problem I see consecutive odd numbers, then it's looking for numbers like 7 and 9, or 33 and 35. Again, they're not next to each other, but if I delete even numbers from a number line, then 7 and 9 would be next to each other because I would have deleted the 8. 33 and 35, if on a number line, 34 is between them, but if I delete the even numbers, they're next to each other. These are consecutive odd numbers, and consecutive odd numbers are 2 apart, just like consecutive even numbers are 2 apart. And they're going to have the same names for the variables. The first number will be x, the second number will be x plus 2. Consecutive numbers like 7 and 8 or 9 and 10, the numbers are 1 apart, so the variables are x and x plus 1. Both consecutive even numbers and consecutive odd numbers are 2 apart. And when numbers are 2 apart and you're trying to find two numbers, you usually call one of them x and the other x plus 2. So these are little just facts that will help us get through the problems a little bit easier, because it'll help us name the variables, and that's kind of the hard part for some of these problems, just figuring out what to call the variables. So as I get into problem 6, the first thing I see is the word product, and product's going to tell me to multiply. And after the word product, it tells me what I'm going to multiply. And then I see that word is. The word is going to be my equal sign. So to the left of the equal sign, I need to multiply. And what do I need to multiply? I need to multiply 2 consecutive numbers. And for 2 consecutive numbers, I'm going to call x the first number and x plus 1 the second number. So to the left of the equal sign, I want the product of 2 consecutive numbers. Product means multiply, and I'm going to show that multiply with the parentheses. So that's what the left side's going to look like. It's a product because it's multiplying, and it's multiplying 2 consecutive numbers, x and x plus 1. I can almost miss the right side. After the word is, the only thing I see is 20. That must mean I need a 20 to the right of the equal sign. Done with the first sentence. The second sentence just tells me to solve the equation, find these numbers. So I have my equation, now I'm going to solve it. I'm going to solve it by clearing the parentheses, because if it's something's factored but not set equal to 0, that's like the last problems in section 1.8, the factoring isn't any help to me. So I'm going to clear this parentheses by going x times x and x times 1. X times x is x squared. X times 1 is positive 1x. Then I get equal to 20. I'm going to do a bunch of algebra, and it's going to be tricky how I write my answer. So stay tuned. If you're working ahead of me, that's an awesome thing to do, but make sure and check your answer, because you might get tricked and not write down the answer exactly how it probably needs to be written down. So just like the last 2 problems, I have a square, and usually when you have a square in a problem that has an equal sign, you want it set equal to 0. I always try to get the 0 on the side that doesn't have the square term, so I'm going to minus 20 from both sides, and that's going to take me to x squared plus x, or I can write plus a 1x minus 20 equals 0. I'm going to factor this. My template for factoring says I need a plus and a minus, and I know I don't need bottoms up because there's not a number in front of the x squared, so I just have to figure out what to do with that minus 20. And for the minus 20, I would have a choice of positive 1 and minus 20, minus 1 and positive 20, positive 2 and minus 10, negative 2 and positive 10, positive 4 and negative 5, negative 4 and positive 5. The pair I'm going to need is this, because negative 4 plus 5 gives me a 1. So inside my parentheses, the one with the plus, I need a 5. The other one, the minus, goes with the 4. And now I'm going to go x plus 5 equal to 0 and x minus 4 equal to 0. For the x plus 5 equal to 0, I get x equal negative 5. For the x minus 4 equal to 0, I get x equal 4. These are not consecutive numbers. Negative 5 and 4 aren't next to each other on a number line. And this problem wants 2 answers for each x. And so what I need to do is, for the 4, that's the first number, I need to add 1 to it. and 4 plus 1 being the second number, which is 5. So one pair of numbers, 4 and 5 are consecutive numbers. They're next to each other, and if you multiply 4 and 5, you get positive 20. So one of my answers to this needs to be the numbers 4 and 5. Because they're consecutive, they'd be, if you wrote down a number line, they'd be next to each other, and they multiply to be 20. The other negative 5 answer, if I take negative 5, which is the first number, and add 1 to it, negative 5 plus 1 is negative 4. That gives me the second pair of consecutive numbers. So there's actually groups of answers. They come with 2 numbers each. Negative 5 and negative 4 are next to each other on a number line, so they're consecutive numbers. And they also multiply to 20 because negative 5 times negative 4 is 20. So my answer should be paired up like this. 4 and 5 are consecutive numbers that multiply, whose product is 20. And negative 5 and negative 4 are also consecutive numbers whose product is 20. So the algebra gave me the first number in each pair, and I had to add 1 to get the second number in each pair. 8's going to be similar, and if you're feeling confident, you might be able to rock 8 without me doing it. 8, I think, has consecutive even numbers in it, so when you set up the left side of the equation, you're not going to have x times x plus 1. So just the wording is almost identical between 8 and 6, but I sneak that word even in there, and that changes what I write on the left side just slightly. So again, I see the word product, so I know I'm multiplying. And I'm multiplying 2 numbers. And I see that the is going to be my equal sign. To the left of the equal sign, I need something that represents the product, so multiplying 2 consecutive even numbers. And that's when the first number we call x, and because they both have to be even, we can't write an x plus 1 because even numbers are 2 apart, or consecutive even numbers are 2 apart. So to the left of my equal sign, rather than having the product of x and x plus 1 when I have consecutive numbers, here I'm going to have the product of x and x plus 2 when I have consecutive even numbers. And then to the right of the equal sign, the only thing after the word is in the first sentence is the number 48. So just like the last problem, I'm going to do all the algebra to solve this. I'm going to get 2 values for x, and each x needs to be paired up with the number that's bigger than it by 2. So clear the parentheses. X times x is x squared. X times 2 is 2x. And then that equals to 48. I need to solve by factoring, which implies I need to get it set equal to 0. So I'm going to get x squared plus 2x minus 48 equals to 0. My template tells me to factor this, I need a plus and a minus. No bottoms up because there's not a number in front of the x. And I'm just going to write down the pair that I know works. It's either going to be 6 and negative 8 or negative 6 and 8. I could have written down the 1 and 48, the 2 and 24, the 3 and 16, the 4 and 12, but I knew those didn't work. I knew the 6 and the 8 were the pair that were going to get me the 2. And the top one, the 6 minus 8, gives me a negative 2. The bottom one, the negative 6 plus 8, gives me the positive 2. So I need a plus 8 and a minus 6. I'm trying to get a positive 2. Now that I have it factored, I'll set the insides of the parentheses equal to 0. I'm going to go x plus 8 equal to 0 and x minus 6 equal to 0. For the x plus 8, I'm going to subtract 8 from both sides and get x equal to minus 8. For the x minus 6, I'm going to add 6 to both sides and get x equal to 6. That's not good enough for an answer because negative 8 and 6 aren't next to each other on a number line when you delete the odd numbers. So for the 6, I'm going to add 2 and go 6 plus 2 and call 6 the first number, and the second number is going to be 8. So in my answer, one pair of consecutive even numbers that I'm going to work with are the numbers 6 and 8. 6 and 8, their product is 48, and on a number line without odd numbers, they're next to each other. For the negative 8, I'll do the same thing. I'll go negative 8 plus 2, and that's going to be negative 6. And the other pair of my answers are negative 8 and negative 6, because, again, both of these pairs of numbers, if you multiply them, negative 8 times negative 6, or 6 times 8, you get 48. And on a number line without odd numbers, they'd be next to each other, because the 7 and the negative 7 that's between these makes these, consecutive even numbers, because they're next to each other if you don't write odd numbers. Hopefully, you could do problem 10 now, because problem 10 really feels a lot like number 8, and it's not that different than number 6. The best thing you could do is pause the video and do this, but if you're not ready, then I'll do it for you. So, just like the last two problems, I see the product, so I know I get multiply. I see consecutive numbers. That's either x and x plus 1 or x and x plus 2, depending on the word after consecutive. And because it's consecutive even numbers, I know I would need an x and an x plus 2. I see my is for my equal sign. To the right of the equal sign is 15. So for this problem, oh gosh, I'm going to get I better change the words here. Let me change this problem to say consecutive odd numbers. Sorry about that if you're working ahead of me and you got an answer. Your answer's not going to be even numbers. This is because this is a new section. First time I'm lecturing on it. I have a little glitch there. The glitch is the word even should be odd. And I'll change that so when you print it out, you won't even see that word. You'll be looking at something and you'll think I'm an idiot, and it's probably not half untrue anyways. So with this fix, I'm still consecutive odd numbers and consecutive even numbers. Still, when you set the variable names up, they're x and x plus 2. So when I go to do the left side, I'm going to find the product of two consecutive odd numbers. I'm going to call the first number x and the second number x plus 2. To the left of my is, to the left of my equal sign, I'm going to put the product of these numbers, which is x and x plus 2. To the right of the is, I put the number 15. I was kind of doing the math in my head, and I realized my answer was going to be odd numbers and not even numbers. And so I punted and fixed the problem before I got too deep into it. Now I'm going to solve it by clearing the parentheses. X times x and x times 2 makes the left side x squared plus 2x. Clearing the parentheses doesn't change the right side. I need to get the problem set equal to 0, so I'm going to minus 15 and minus 15. I'm going to get x squared plus 2x minus 15 equals to 0. A lovely plus and minus for my factoring. My choices would be 1 and negative 15, negative 1 and positive 15, 3 and negative 5, or negative 3 and positive 5. This is the pair that's going to work, because negative 3 plus 5 gives me the positive 2 that I need to. So I'm going to put a plus with the 5 and a minus with the 3, set equal to 0. Then I'll set the insides of the parentheses equal to 0. I'll go x plus 5 equal to 0, x minus 3 equal to 0. For this one, you'll minus 5 from both sides and get x equal to minus 5. For that one, you'll plus 3 from both sides and get x equal to 3. That's the first number in the pair, because negative 5 and 3, they multiply to negative 15. They don't multiply to positive 15, and they're not next to each other on a number line without even numbers. So for each x, I need to get an x plus 2. So I'm going to add 2 to 3 and get my first pair in my answer. And that first pair is going to be the numbers 3 and 5. 3 and 5 are next to each other on a number line if you throw out the even numbers, and they multiply to 15. And for the next number, negative 5, I'll go negative 5 plus 2 and get negative 3. And also, negative 5 and negative 3 are considered consecutive odd numbers as opposed to even. They're next to each other if you delete the negative numbers from your number line, and they multiply out to be positive 15, so they're perfect for my answers. All right, now on some geometry problems. The next two problems have to deal with rectangles. Usually I draw pictures, and generally when I draw a picture of a rectangle, the length I call the longer direction and the width I'll call the shorter direction. Kind of doesn't matter, but that's usually how we do it. So just in general, a generic rectangle that I might draw has 4 sides, and the sides that are longer I call lengths, and the sides that are shorter I call widths. I do that. I'm consistent for all rectangles that I do that on. So now I can't have two variables, and the first sentence is going to help me get the letters for this problem, and it'll help me get down to one letter. So the first sentence, it has is, so I'm going to get an equal sign, and for length, which is written first, I'm going to write the letter L, and I see this lovely is. So this whole left side of the first sentence, the length of a rectangular bedroom is, I'm going to change that to this simple L equals. So the whole of the rectangular bedroom, I'm not going to incorporate into my word problem at all, or into the beginning here. And then the next thing I see is 3 feet longer than its width, and that's where it requires being clever. It's not being so clever if you've done a lot of word problems like this before. If you've never or haven't recently done a word problem like this, it requires a lot of thinking to figure out what to replace 3 feet longer than the width. Longer, it doesn't really feel like it's a multiply, subtract, and add, or a divide, but in this context, longer is a plus, and it's 3 feet longer than the width, so it's the width plus 3. So always in rectangle problems, L is going to mean length for my letters, and W is going to be width. And in this problem, the length and the width are related. The length is 3 more than the width. So I'm done with the first sentence. Now I'm going to move on to the second sentence, and the second sentence tells me the area, and that's another thing I need to know in order to do this problem well. So I know that when I draw rectangles, I make the lengths the longer sides, the widths the lower sides. The letters I use for length are L, width is W, and the other thing I'm going to need before I can get into this problem is the area formula. And the area of any rectangle, usually we call it A, is found by multiplying the length times the width. We don't need to remember much geometry, but that's some of the geometry that we need. So now I'm going to dig into the second sentence. The second sentence says the area of the bedroom, or the area of the rectangle, is 108. The is 108 part's the easy part for me. Is equals, and after the equal, it's 108. And I'm not going to put the square feet in. I won't worry about the units. They'll just kind of work their way through the problem without me having to write them. To the left of the is, I need the area, which is the length times the width. The length is W, so generally I would say length times width, which is the area of this rectangle, needs to be 108, but that's not going to do me very well because I don't know how to solve this problem with the two variables. So what I'm going to do is I'm going to replace the length with W plus 3. And the equation I'm going to attack and solve is width length w plus 3 times width equals 108. 108 is a really unpleasant number, but I'll deal with it in a second. So just like every word problem that has a parentheses in this section, I need to clear the parentheses. And this one's harder for me to clear, and I can flip the order of the parentheses without changing what the left side means. It's going to make it easier for me to multiply. So I just did a one step that you don't have to do, but it makes it easier for me to get this problem going. Now I'm going to clear this parentheses by going w times w, which is w squared, w times 3, which is 3w, equals 108. I'm going to solve it by factoring. I need to get it set equal to 0, just like every problem so far in this section. And I'm going to get w squared plus 3w minus 108 equal to 0. If you're working ahead of me, again, you might fall into a trap. In the last few problems, I got pairs of solutions, and in this problem, it's almost going to look like we're going to get pairs of solutions again, but one of the answers is negative, and somehow we'll discard that, and I'll get to that in a second. Horrible, horrible that I'm asking you to factor this. So I'm going to go w plus and w minus from my template, and then 108. I just don't know factors of 108. Let me do 108 divided by 2. That tells me that I might get like a 2 and a negative 54, or a negative 54 and a 2. That's not going to give me a 3. I'll move on to 3. I'm going to go 108 divided by 3. That tells me I can do like a 3 and a negative 36, or a negative 3 and a 36. That's not close to a 3. Let me try 6. I could try 4, I guess, but I'm going to jump up to 6. 108 divided by 6 is 18. That would give me 6 and negative 16. Those are 10 apart, getting closer but not far enough. I don't think 7 goes into it. I don't think 8 does, but I'll try 8. 108 divided by 8 gives me a fraction, so that's no good. I don't think 9 goes into it, but maybe it does. 108 divided by 9. Oh, it does. I didn't think it did, but it actually went into it. So 9 times negative 12 and negative 9 times 12 are, they'll multiply to negative 108, and they have the 3 that I need. This is going to be the pair that I need. So notice how I don't know 108 so well, so I just resorted to my calculator, and I could have started dividing every number. I could do 108 divided by 2, 108 divided by 3, 108 divided by 4, all the way up until I got to 9. I would have found the pair. If I got a fraction when I divided, it wouldn't belong in this list at all. And if I didn't get a fraction, I put it in this list, but I discarded it if the numbers weren't 3 apart. So this is going to factor into plus 12 and minus 9 equal to 0. Now I'm going to go w plus 12 equal to 0 and w minus 9 equal to 0. The w plus 12 gives me width equal to negative 12. The w minus 9 gives me a width equal to 9. Usually, when we do a word problem, we keep all the answers because they fit the equation. In geometry word problems, we only keep the positive answers because the width of a room can't be negative 12. So in geometry word problems, which are going to be rectangle and triangle word problems, we throw out any negative number answers, unlike the other problems where we needed to keep them. And the reason we were allowed to throw them out, because this tells me, in this case, in feet, how long the bedroom is. And I can have 9 feet for my length, but I can't have a negative 12 feet. 0 would be the shortest. You can't have negative lengths. So, about ready to write my answer. Unfortunately, I'm not complete. My algebra gives me one of the numbers, but it doesn't give me both of them, because this just gives me the width, And the word problem asks for a length and a width, but I know how to find the length because the length is the width 9 plus 3, because the length is 3 feet longer than the width, and I'm going to get, for the length, I'm going to get 12 feet. It's nice if I put feet because I'm dealing with physical lengths, and the lengths are in feet. So a couple of twists, throw out negative answers. Just like the last 3 problems, the algebra gives me one number, but I'm asked for 2 numbers, so I'm asked to find the dimensions of the room, which are the length and the width of the room. I think 14 is going to have a similar feel. Talks about a rectangle again. In case it talks about a garden, and it's 3 feet narrower. The narrower is a width. So the picture in this garden, it looks like it's a little bit longer than it is wide. And the first sentence tells me how the length and the width relate to each other. And being 3 feet narrower than it is long means the width is 3 feet less than the length. So my width part of this rectangle is going to be 3 less than the length because it's narrower than it is long. And the length is just going to be length. So this is my picture for this particular garden. The width is 3 narrower or 3 less than the length. Always in these rectangle problems, one of the letters is just a letter by itself, and the other letter gets a plus or a minus sign. Done with the first sentence, I know how the length and the width relate. The second sentence tells me the area is 54, and for area I go length times width has to be 54 square feet, but I'm not going to use 2 letters. I'm going to change the W to how it relates to it in this problem, which is L minus 3. Now I'm going to clear the parentheses. L times L is L squared. L times minus 3 is minus 3L. Then I have equal to 54. I'm going to minus 54 and minus 54 and get L squared minus 3L minus 54 equals to 0. And I know this is a plus minus. And I know it's a 6 and a 9. It's either going to be a positive 6 and a negative 9 or a negative 6 and a 9. I didn't need to write all the factors of 54 because I knew the ones that I needed. And the pair that's going to work is the 6 minus 9, because 6 minus 9 gives me negative 3, but negative 6 plus 9 gives me positive 3, and I'm trying to get that negative 3. So I need a positive 6 and a negative 9 equals to 0. And now I'm going to go L plus 6 equal to 0 and get L equal to negative 6, and L minus 9 equal to 0 and get L equal to 9. And then in geometry problems, that's what this is. A rectangle is a geometry problem. I ignore or throw out negative answers because lengths and widths of rectangles can only be positive. So when I go to write my answer for 14, I'm going to say the length is 9 feet, and in order to get the width, it's 3 feet narrower, so the width is the length 9 minus 3. I'm going to say the width is 6 feet. Now we have a triangle problem. And in triangles, there's going to be 2 formulas that we might need for triangles. And you may not remember them. I mean, there's no reason to remember them if you haven't done geometry in a while. The 2 formulas that I'm going to need in a triangle, one's just for any triangle. So for triangle formulas that I'm going to need to deal with these word problems, one is the area formula. And the area of any triangle is 1/2 the length of the base times the length of the height. So usually symbolically we say 1/2 base times height. And in a triangle that I'm not told anything about it being a quote-unquote right triangle, the picture that I usually draw will look, something like this. I'm going to draw a triangle, and then I'm going to make a line that goes from one corner to the other side that meets the other side at a right angle. That's what I'm going to call the height. And then the side where this dotted line from a corner intersects, I'm going to call that the base. So B being the base and H being the height. That's the picture I'm going to draw in problem 16. And then when I get a little bit deeper, it's going to start talking about hypotenuses and right triangles. And for hypotenuse and right triangles, I have a different picture that I draw and a different formula that I need. So one formula I'm going to need for triangles works for any triangle. Its area equals half the base times the height. The other formula I'm going to need for triangles, and it only works for right triangles, is the Pythagorean Theorem. And that theorem is a squared plus b squared equals c squared. And usually I do this. I call A, we call it the short leg. B, we call it the long leg, and that's probably not the best name, but that's what we call it. And C we call the hypotenuse. Turns out that the hypotenuse is actually the longest. There's 3 sides to every triangle, and in a right triangle, I'm going to make A the shortest side, B the middle length, but the non-hypotenuse are called legs, and C I'm going to call the longest side. So pictorially, for right triangles, I usually make something that looks like this, and I do this little hitch there. So the hypotenuse is directly opposite the right angle. So this side's the hypotenuse, and it's the longest side in every right triangle. I'm going to call it the C. And then the other 2 sides are called the legs. The shorter leg I'm going to give the letter A, and the longer leg I'm going to give the letter B. I draw my triangles this way, but you could make the longer leg the vertical one and the shorter leg the horizontal one. It's not going to matter. Our pictures don't need to be spot on accurate. They just need to be kind of okay. So for the next 2 problems, I'm going to use this kind of diagram, and I'm going to use the area formula. And then after that, we'll start talking about right triangles. And in right triangles, triangles that have a right angle in them, I'll need this picture and this kind of setup. And I'll come back to this as we need it. So for problem 16, I need to deal with just a generic triangle. It's not a right triangle. So I'm going to draw a picture of this the best I can. So it's a generic triangle. Again, this may have nothing to do with how the triangle really looks, but for me it's going to be good enough to answer the questions and draw a picture. So for the first sentence, I'm going to try to draw a picture of this triangle, and it's definitely not drawn to scale, but I hardly care. So the first sentence, I need a triangle, not a right triangle, and the base is 1 foot longer than the height. So the height is this part right here, and this is the base down here, and the base is 1 foot longer than the height, so I'm going to say it's height plus 1. Kind of cool. That's my triangle, and I'm done with the first sentence. I have a picture. I know the height is my H, and my base is normally a B, but I can't have 2 letters, so I'm going to make it the height plus 1. Now I'm going to move on to the second sentence. The second sentence tells me the area of this is 10 square feet. So usually the area is 1/2 the base times the height would be 10 square feet, because the area of any triangle is 1/2 the base times the height. For all our word problems, I need to get from 2 letters down to 1 letter, and I'm going to get from 2 letters down to 1 letter by replacing the base with h plus 1. Again, if you're speeding ahead, I'd love that, but there's going to be a trick here. That's a real important trick to learn for these triangle area problems. So this is a nasty thing to solve because it has a fraction that I haven't dealt with before. Anytime you have a problem that has an equal sign and a fraction, if you're clever, you can get rid of the fraction, and that's what I'm going to try to do. I'm going to be clever, and I'm going to multiply both sides by 2 before I get any deeper into the algebra. And what that does, it doesn't change the answer, but it's going to make the problem a heck of a lot easier, because on the left side, when I multiply 2 times 1/2, the reason I picked 2 is because it's the reciprocal of 1/2, and all the triangle problems that have area I'll multiply by 2. Because if you go 2 times 1/2, you get 1. So I've canceled out the fraction, and that makes 1 times h plus 1 times h left on the left side, and it makes 20 on the right side. Again, I like multiplying differently, so I'm going to rewrite the left side. I'm taking an extra step just to make it easier for me to clear the parentheses, but you can clear the parentheses without doing this rewrite. Now I'm going to go h times h is h squared, h times 1 is plus 1h, and I get equal to 20. And then minus 20 minus 20 gives me h squared plus 1h minus 20 equals to 0. Then I need to factor this, and I know it's a plus minus, so I'm going to do an h plus and an h minus, and I think it's a 4 and 5. It's either a positive 4 and a negative 5, or a negative 4 and a positive 5, and I guess it's this one, because 4 minus 5 is going to be negative 1, but negative 4 plus 5 is going to be positive 1. So I'm going to put a plus 5 and a minus 4, set it equal to 0. Now I'll go h plus 5 equal to 0, which gives me h equals to negative 5, and h minus 4 equal to 0, which gives me h equal to 4. In all geometry problems, the numbers stand for physical lengths usually, and you can't have a length of a negative 5 again. So for geometry problems, which are for us triangle and rectangle problems, throw out the negative lengths, because you can't have, or negative answers, because you can't have negative lengths. So for this problem, the algebra tells me that the height is 4, and then I'm going to put feet. Turns out that that's all this asks for. If I didn't read close enough, I was getting ready to say what the base is, and I wouldn't care if you said the base is 4 feet plus 1 feet is 5 feet. It's not asked for, but I don't care. If you give me more than it's asked for, that's okay. Usually, I ask you for all the dimensions, but for whatever reason I only asked you for one of the dimensions. So technically you don't have to give the base, and you only have to give the height. But if you give me both, it's completely fine. I don't care. You give me more. As long as you get the part that's asked for, you're fine. So this actually works, because the area of this triangle is half the base times the height, and half of 4 times 5, half of 4 is 2, times 5 is 10. So a triangle that's 4 foot by 5 foot has an area of 10 square units, and the base is 1 more than the height, so it's perfect. 18 should feel a lot the same. And again, I draw the same triangle even if it doesn't kind of work for the problem perfectly. So it's not a right triangle, so I'm drawing a triangle that's not a right triangle. Draw my height in. So this is my height, this is my base. Go to the first sentence. The first sentence says the height is 3 feet shorter than a base. I'm going to get that into my picture. For the height to be 3 feet shorter than the base, then my height has to be the base minus 3. That's 3 feet less. So this is the triangle that I'm dealt with. Done with the first sentence, it gave me the triangle picture. Now I'm going to do the area. The area of any triangle is 1/2 the base times the height. In this case, 1/2 the base times the height is going to be 1/2 the base times b minus 3, because the height is b minus 3, and the area has to equal 20. That's the equation I'm going to solve. And it's going to give me the base. I want to find the height, so I'm going to subtract 3. So here, this is the height equals the base minus 3. Just like in the last problem, I'm going to multiply both sides by 2. On the left side, 2 times 1/2 is going to cancel and give me a 1 and leave me with just b times b minus 3. On the right side, 2 times 20 is going to give me 40. Now I'm going to clear the parentheses. I'm going to get b squared minus 3b equals 40, and then minus 40 minus 40, b squared minus 3b minus 40 equals to 0. And now I'm going to look at the factors of 40. 1 and negative 40, because this is a plus minus factoring again. That's not close enough. I'm not going to try the other one. 2 and negative 20. 2 and negative 20 aren't close enough. 3 doesn't work. 4 and negative 10, that still doesn't work. 5 and negative 8, that's actually the pair that I need, because 5 times negative 8 is this negative 40, and 5 minus 8 is negative 3. So I'm going to do plus 5 and a negative 8, and then I'm going to go b plus 5 equal to 0, b minus 8 equal to 0. The b plus 5 equal to 0, you minus 5 from both sides and get b equal to minus 5. The b minus 8, you add 8 to both sides and get b equal to 8. It's a geometry problem. I throw out the negative answers. So my answer for the base is 8 feet. It doesn't even ask for the base in my answer. When I go to write my answer, it's okay to say the base is 8 feet. It's not asked for, but I got it. I might even give it to you. What I'm asked to find is the height. And the height is 3 feet shorter than the base, so it's 8 minus 3, and it's 5 feet. If you gave me that for an answer, it's perfectly fine. It's correct. It's overkill. Or if you only gave me the height was 5 feet, that's completely fine too, because that's all it asks for. But giving both, I'm completely content with that. All right, I think we're on to the Pythagorean Theorem problems. Could be wrong, but I think that's what's next. Yes. So that means I have to have the theorem and picture in my mind. So Pythagorean Theorem problems, I'm going to draw this triangle. Even if it doesn't fit perfectly the words in the problem, it will be good enough for all the word problems we get. Maybe if you get into a trig class where they do just ridiculous amounts of right triangle work, you'll get a little more precise in how you make your right triangles. But for us, it's completely fine to make this for every time I see a hypotenuse right triangle problem. So now I'm going to have to go through this problem, and it's going to be a little bit different. It's not using the area formula anymore. I'm using the a squared, b squared, c squared formula, and that's, I don't know if it's easier or harder, it's just different. And so patiently I look at the problem, and it's my first one of these, so it's, maybe a little bit intimidating, but the nice thing is when you get to a test, it won't be the first one. So if I decide to give you a word problem on a test, it certainly has to be just like one of the word problems that we did. So won't have to be that creative on our tests. So I'm going to draw my picture. I have this side A, side C, and side B. I don't know if I need to put these letters in, but this is A, C, and B for me. A again is the short leg, B is the long leg, C is the hypotenuse. And as I read this right here, so for me, A is my short leg, B is my long leg. Seems like a horrible name for it, but that's generally what we call these things. And C is the hypotenuse. Do that for all these triangles. And so the first thing I see is the length of the hypotenuse of a right triangle. So I drew a lovely right triangle is 4 inches more than the shortest leg. So the shortest leg is going to be A. This C is going to be A plus 4 inches because it's 4 inches more than the shortest leg. Done with the first sentence, got that incorporated in my picture. Now I'm going to move on to the second sentence. The second sentence says the length of the longer leg, which is my B, is 2 inches more than the shortest leg. The shortest leg is A, so this is going to give me this side, B, which is the longer leg, is A plus 2. Done with the first two sentences means I must be able to get my equation now, because now I need to find the length of each side. And so I'm going to use the formula A squared plus B squared equals C squared. But I need to fix it up. So I'm going to use A squared plus B squared equals C squared. But instead of B, I'm going to put A plus 2. Awful. And instead of C, I'm going to put A plus 4. This is going to be the most tedious algebra that we've had so far, but it's not going to be a horrible problem when we get done with it all. So I need to clear these parentheses. The first parentheses, A plus 2 squared, I'm going to rewrite it as A plus 2 times A plus 2. The second parentheses, A plus 4 squared, I'm going to rewrite it as A plus 4 times A plus 4. I'm going to FOIL now. On the left side, I'm going to do, on the first parentheses, I'm going to do first, which are A times A, which is going to give me an A squared. And then outers, A times 2, which is going to give me a positive 2A. Inners, 2 times A, which are going to give me another positive 2A. And lasts, 2 times 2, which is going to give me a plus 4. Bring down my equal sign, FOIL the other side. The other side, firsts are A times A, which is A squared. Outers are A times 4, which is positive 4A. Inners are 4 times A, which is positive 4A. And lasts are 4 times 4, which is positive 16. Need to simplify each side. On the left side, the A squareds have implied 1s in front of them. So when I'm simplifying the left side, 1A squared plus 1A squared is going to give me a 2A squared. 2A plus 2A is going to give me a 4A. The 4 is going to stay 4. On the right side, the outers and inners are going to give me an 8A. And again, the A squared, there's an implied 1 in front of it. I'm going to get this problem set equal to 0. And what I'm going to do is I'm going to minus 1A squared, minus 8A, and minus 16 from both sides. On the left side, 2A squared minus 1A squared is 1A squared. I don't really have to write the 1, but I can. 4A minus 8A is negative 4A. 4 minus 16 is negative 12. On the right side, I made everything pop out to 0 because I subtracted everything. I need to now factor the left side. and it's a plus minus factoring, so I'm going to go a plus and a minus, and then my choices are 1 and negative 12, negative 1 and 12, 2 and negative 6, negative 2 and 6. I already have the pair, I'm not going to go further. This pair is the one that's going to work. So I'm going to do plus 2 and minus 6. And now I'm going to go a plus 2 equal to 0, which is going to give me a equal to minus 2, and a minus 6 equal to 0, which is going to give me a equal to 6. Geometry problems, I throw out the negative solutions because lengths of objects can't be negative. I have one of my answers, but I'm supposed to find the length of all three sides. So a is going to be 6, and if I read through the problem again, it's inches. So I'm going to say the side A is 6 inches. B is a plus 2, so it's going to be 8 inches. And C is a plus 4, and 6 plus 4 is 10 inches. So I'm done. I'll just move on to the next right triangle problem. I think we have just a few more problems left, maybe 3. All right, another right triangle problem headed our way. Problem 22. Again, it tells me hypotenuse, right triangle, so I know I'm dealing with the same drawing. My A is my short leg. My B is my longer leg or long leg. And my C is my hypotenuse. This is my A, this is my B, this is my C, there's my right angle. First sentence says the length of the hypotenuse is 2 more than the longer leg. That means C is B plus 2. Second sentence, it says the length of the shorter leg is 2 less than the longer leg. That means A is B minus 2. So each sentence tells me how to get a side with a letter. Now I'm going to use same thing, a squared plus b squared equals c squared. Instead of a squared, I'm going to write b minus 2 squared. Instead of c squared, I'm going to write b plus 2 squared. Clear my parentheses. So b minus 2 squared is b minus 2 times b minus 2. B plus 2 squared is b plus 2 times b plus 2. Oh, this is going to be a tricky problem, which is not such a bad thing. It's one of these problems that the factoring is going to be so easy that it's hard for you. So FOIL this. First, b times b, b squared. Outers, b times minus 2, minus 2b. Inners, minus 2 times b, minus 2b. Last, minus 2 times minus 2 is positive 4. Bring down the b squared. Right side, first, b times b is b squared. Outers, b times 2 is plus 2b. Inners, 2 times b is plus 2b. Last, 2 times 2 is 4. And on the left side, I need to combine the b squareds. 1b squared plus 1b squared, just like the last problem, is 2b squared. And then minus 2b is minus 4b. And then plus 4. On the right side, you get b squared plus 4b plus 4. I'm going to set the problem equal to 0, and if you're working ahead, which I love, you're going to run into a trick that you might not seen before. So I'm going to minus 1b squared minus 4b minus 4 from both sides. On the left side, this gives me 2b squared minus 1b squared is b squared, minus 4b is minus 8b, and the 4's cancel. On the right side, I get a 0. Now, when I continue working the left side, it's all of a sudden not something we've done recently. this is just common factor factoring. To solve this, I'm going to factor out a b from the left side and get b times b minus 8 equals 0. So it's not two parentheses factoring, it's just common factor factoring. And then I'm going to go b equal to 0, b minus 8 equal to 0. It gives me either the base is 8 feet or the base is 0 feet. The base of a triangle, it can't be negative. It also can't have a length of 0. So my answer to this problem, the base is going to be 8 feet. So it was only, because there weren't 3 terms, I knew I probably wasn't going to, well, because there was a common factor, I had to factor it out first. And after I factored out the common factor, it was done. So I'm almost ready to answer the problem. B is 8. A is b minus 2, so it's going to be 6. And C is b plus 2, so it's going to be b plus 2, which is going to be 10. And then the word problem says these are in feet, so I might as well tack the word feet onto these. So these are a little bit harder than the rectangle problems. I think the last group of triangle problems actually get easier than these two. But they're different, which could also make them harder. And maybe it's about the same. So hypotenuse right triangle, I'm drawing my picture. Again, this picture is going to get me through every word problem that we do. So this is my A, which is my short side, my B, which is my long leg, and A is my short leg, B is my long leg, C is the hypotenuse. And in this one, it's a little bit different. The first sentence actually tells me the length of the hypotenuse. It says the length of the hypotenuse is 10 inches. Not 10 inches more than anything, just flat out 10 inches. So my C is going to be 10. Done with the first sentence. It's really nice that I know what one of the sides. Second sentence, the short leg is 2 inches shorter than the long leg, which means A is 2 inches shorter than B, so it's B minus 2. Then I'm done with the second sentence. Now I'm going to use the Pythagorean Theorem, which would be A squared plus B squared equals C squared. For A squared, I'm going to do B minus 2 squared plus B squared, I'm going to leave B squared. And for C squared, I'm going to write 10 squared. This actually might be harder than the last problems. I thought it was going to be easier, but I think the factoring is going to be trickier. So now I'm going to go B minus 2 times B minus 2 plus B squared equals to 10 squared. Foil this. First are B times B, which is B squared. Outers are B times minus 2, which is minus 2B. Inners are minus 2 times B, which is minus 2B. Lasts are minus 2 times minus 2, which is plus 4. Then I have the B squared, and 10 squared is 100. On the left side, I need to combine the B squared, and 1B squared and 1B squared is 2B squared. The minus 2B and minus 2B give me a minus 4B. The plus 4 gives me a plus 4, then equals 100. I need to set it equal to 0, so I minus 100 minus 100 and get 2B squared minus 4B minus 96 equals to 0. And now I need to solve by factoring. I'm going to pull out my common factor of 2, and this is going to give me 2 times B squared minus 2B, I think that's 48, but I'm going to do it on my calculator. 96 divided by 2 is 48. So I get 2 times B squared minus 2B minus 48 equals to 0. Then I'm going to go 2, and then B plus, and B minus. And then for 48, I think it's going to be 6 and 8. I have to figure out if it's 6 and negative 8, or negative 6 and 8. 6 minus 8 gives me negative 2. Negative 6 plus 8 gives me positive 2. So I need the 6 and the minus 8. And now I'll go 2 equal to 0. B plus 6 equal to 0. B minus 8 equal to 0. Any factor that doesn't have a letter doesn't give a solution that checks. The middle one, you get b equal to -6. The far right one, you get b equal to 8. And for geometry problems, I ignore the negative lengths because you can't have negative sides. So the answer to this is the base b equals 8. And then these are in inches this time, so I'm going to say inches. A is b minus 2, so A is going to be 6 inches. And it doesn't ask for C, but it's not wrong to give it. C is the 10 inches. So it only wants the A and the B. It wants the lengths of the legs, and it gave me the hypotenuse, but I gave you the hypotenuse back. One more, I think it's just like 24, and then we'll be done with the word problems, and hopefully you don't feel like you're sinking on these things, and they aren't the worst word problems you've ever seen. Okay, another right triangle, so I'm drawing my right triangle. My A is my short leg. My B is my long leg. And my C is my hypotenuse. First sentence, the length of the short side is 5 inches, which means this A doesn't have a letter, it's going to turn into the number 5. Second sentence, the longest leg is 1 inch less than the hypotenuse, so this is C minus 1. Find the length of the unknown side, so I'm going to use A squared, 5 squared, plus B squared, C minus 1 squared, equals C squared. Well, this is a nice problem. So this is going to be 5 squared plus C minus 1 times C minus 1 equals C squared. 5 squared is 5 times 5, which is 25. And then first, C times C is C squared. Outer, C times minus 1 is minus 1C. Inners, minus 1 times C is minus 1C. Lasts, minus 1 times minus 1 is plus 1. Equals C squared. I'm going to combine the minus 1C's and get a minus 2C. And combine the 25 and the 1 and get a plus 26. This is a really nice way to end things off, although it's different, so maybe it's not so nice. So I'm stuck with C squared minus 2C minus 26 equals C squared. Usually when we have squareds, we set it equal to 0, so I'm going to set it equal to 0. When I minus the C squared from both sides, something unusual happens. Both the C squareds cancel. And I'm left with a problem that doesn't have a square. When a problem doesn't have a square, you don't factor. You get the numbers on one side, the letters on the other. And I don't have the numbers on one side, the letters on the other, because I thought I was going to need to factor because I had the squared, but they canceled out. So now I'm going to resort to the strategy that I use when I have no squared term. Get the numbers on one side, the letters on the other, and you solve by dividing. This gives me 13 equals C. So I'm going to go for my answer. My answers are in inches. So I'm going to say the C is 13 inches. B is C minus 1. So B is going to be 12 inches. And the A was given at 5 inches. I can certainly give it, but it's not actually asked for. In the instructions, it just asks for the unknown side. So that's every word problem, every even word problem. Hopefully, you don't feel like you're sinking in these word problems, and you can kind of roll through the section without a lot of difficulty. Again, stop in and visit me or shoot me an email if there's just something you're just not getting, and I'll try to make it better.